All right, so today we're talking about functions. Our goal for today, I can identify whether a relation is a function. So if you know why these are or are not functions, and you could tell me why, then you can give yourself a 3. If you're like, nope, haven't heard of it before, a 1, and maybe you're a student from Algebra 1 last year, and you're like, I remember doing this. I think it's this. I think I struggle with the why, but I got what a function is. So far, we've seen relations, which are just a connection between two variables. A function is a special type of relation. A function is a relation where each input pairs with one consistent output. So I like to say each input pairs with exactly one output. So that's one way of looking at it, okay? Now, when you're looking at ordered pairs versus when you're looking at a graph, there's two different reasons why you can always say the same reason, or you can say, I'll teach you two different ways. So here's some examples. Determine whether each relation is a function. So this input of 2 is giving an output of 3. Input of 5 giving an output of 1. So far, so good. This input of 2 is giving an output of 0. So if you look right here, we just said 2 gives an output of 3. Let me erase this one because it doesn't matter. But 2 also gives an output of 0. So each input isn't giving exactly one output. It's giving two different outputs. So I'm going to say, no, this is not a function. And my reason why is because the input of 2 has two different outputs. The input of 2 has two different outputs. You can be more specific. You can say the input of 2 has outputs of 3 and 0, okay? But I like the way I said it. All right, let's check this one. Negative 3 outputs 0, 2 outputs 7, 4 outputs 1, 5 outputs 0. So there's no x value that outputs two different y values. So is this a function? Yes. And my answer, which is going to be an answer that you're going to learn to know and love, every input has exactly one output. Every input has exactly one output. Every input has exactly one output. It's a sentence or a statement that you should know very well, okay? Every input has exactly one output. You're going to write it a ridiculous amount of times throughout your math lives in high school. Okay, next, I want to look to see if this is a function. So if I look here, this point right here, it's an input of negative 4, right? And it's giving an output of positive 4, okay? All right, the next one, input of negative 2, giving an output of 0. This one's an input of 1, giving an output of 3. And an input of 1 giving an output of negative 4. So if you think about this, this is 1, 3. 1's also outputting negative 4. So no, this is not a function. So there's two different ways you can say this. You can go back just like the one above it and say the input of 1 is giving two different outputs. That's absolutely fine. Another way of saying it is if you look right here, I can see that if I draw a vertical line through this, it hits the graph twice, and that will happen if you get two different outputs. So you could also say doesn't pass the vertical line test. Doesn't pass vertical line test. All right, let's look at this one. Is this a function? So I'm going to go back to that vertical line test. If you look at the vertical line test, I'm hitting the graph more than once when I draw vertical lines someplace. So this is not a function. And once again, I'm going to say doesn't pass vertical line test. Vertical line test. You can call the vertical line test the VLT, vertical line test. okay? You could have also said, you could have given a specific example. You could have said the input of 1 gives 2 different outputs, right? The input of 1 gives 2 different outputs, or the input of 2 gives 2 different outputs, or the input of 3 gives 2 different outputs. You can say that. That's absolutely fine. Okay, next it says the relation in the table below is missing a value. So notice this X value right here is missing. A says, of the options listed below, which one could be placed in the red box so that the table would still be a function? So let's start with -4. So what I have to keep in mind is -5 has to always give me a 2, 1 always has to give me a 5, 3 always has to give me a -1. So it's saying, can -4 give me 6? Sure it can. All right, let's change this to 0. Can 0 give me 6? Absolutely. 0 is not giving me anything else. Okay, oops. Can 1 give me a 6? So now if you look here, 1's giving you a 5 here. 1 can't give me a 6. So this is not working. All right, keeping going here. I want to know, can 2 give me a 6? The answer is yes. What about 3? Can 3 give me an output of 6? Absolutely not, because 3's already given me an output of -1. Can 6 give me an output of 6? Yep. How about 10? Yep. Should probably circle this in pink. It's weird that it was in green. All right, next it says, of the options listed below, which ones would be placed in the red box so that the table would no longer be a function? So now we're trying to make it so that it's not a function. So -5. Oh, that's not a function because -5 is giving me an output of 2 here and then 6 here. So that's not going to work. All right, next one, -3. Nope, that's not going to work. 0, no, 0 would be fine and make it a function. 1, nope. 1 has to give me an output of 5. +3. Oh, wait, -3 was fine. My bad, I read this as a -3. -3 is fine. +3 does not work because +3 gives me an output of -1. I accidentally thought it was -3 for a second. What about 5? 5 is fine. And 6 is also fine. Wait, we'll make it no longer be a function. Whoa, girl. Let's go back to 1. 1 doesn't work. So that's good. All right, 3, it would no longer be a function. 5, it would still be a function. 6, it would still be a function. There we go. I got my directions mixed up halfway through the problem. Okay, draw a graph for each description. So now we're using things that we learned in previous notes and stuff we just learned. I want to draw a discrete relation, which is a function. So remember when you look at a discrete relation, it looks like points. So this right here, 3, is a discrete relation, but this one is not a function. I want to draw one that is a function. So I'm going to start drawing some points, but I'm not going to draw any that are vertically from each other. I can do ones that are horizontally, but just not vertically from each other. So there's my example. I just made it up. A continuous relation, which is a function. Okay, I'm going to draw this. All right, it's continuous, and it's passing the vertical line test. Next one says draw a discrete relation, which is not a function. So I could, watch this, hold on. I'm going to copy and paste, watch this. Copy and paste this, right? And I can move it exactly where this was, and this right here is a function, but as soon as I add an extra point vertically from any of the points I already have, so like if I added a point right here, now it's not a function. A continuous relation, which is not a function, so I want it to not pass the vertical line test. So anything extremely ugly, like this, right? That's not going to pass the vertical line test. Or you can just keep it simple. You can make it like a C looking. Like, oops, that disappeared. Let's put that back there. Like C. Right? That doesn't pass the vertical line test, so that's not a function. Okay, so hopefully I didn't confuse you this one when I mixed up my directions, but that's our lesson